Hello everyone, Andreas here. This is part 11 of my robot arm project. And first of all, I want to thank you all for the support. It helps a lot, it keeps me motivated. And before you get too excited, this lower joint is currently not working. There are some big bearings inside, and I ordered them from China because they are a little bit difficult to get in Europe in this size, but they should arrive in about 2 weeks. This part is functional now. The motor is running not at full power because then I have to cool the motor drivers, and also I already damaged the arm with itself with a software error. So I set them arms to a low current, and so we can not damage it. But first I show you some of the movements. So it runs. I have this weight. It's aluminium. It's about 800 or 900 grams. Let's take a measurement. So yeah, it's about 800 grams. So keep in mind the motor is running not at full capacity. Yeah. Well, it's rather dangerous, I think. So as you can see, it's working, and also the power is incredible with this motor here and inside, and the whole construction. It's a major improvement to all my previous arms, and I'm super happy and excited about the results. So let's take a closer look to the robot. That's the power supply. It currently runs on 24 volts. This is the stepper motor for this motor here for the elbow. This is an Arduino Duo with a RAMS FD shield. It's a stepper 3D printer shield. It has 2 stepper motor drivers. They are also not cooled, so you can't run them at full capacity. So the motor sits here, as you can see here behind this. That's the motor, and here will be the large bearings I still missing. Okay, the motor is here. Here's the pulley from the motor, and then inside there's the timing belt with a gear like this. You can buy them on stock. I've machined out it a little bit to make them lighter. They're about 200 grams if you buy them, and now they're at 100. I think they're still tough enough. I added also, I had to add a splint, so I drilled the hole through the axis and put in this small bolt, because the torques are so immense and you can't fix it with a screw on the axis. It won't work. So I have to do this here also. But here I've done it already, because it slipped through. The force is so immense on this part. So I doubt you can 3D print these gears. I think they will break sooner than later. Then from back to the arm. From then here, timing belt goes there, and it already cut this gear loose. That's what I meant with damage the arm itself. So I enforced it, added a few screws and a lot of acetone to fix this. The rotation motor here sits here and drives with a small pulley this gear, and this small pulley drives the gear attached to the forearm. The motor on the forearm has this pulley inside here, and then we have this twisted belt. It's twisted on 90 degrees and here 90 degrees again to get to the position on the front. Then if you go on the other side, here's a small pulley again and a belt tensioner, and this one. The encoders are as last time, absolute encoders. One is here, one is inside there to measure the angle there, one is here, and one will be attached here. So in the front is some cheap robotic servo, but this part I think is quite easy to replace if you want to use something else. And the most of the cables running quite good inside. I think this solution is okay, because I didn't get large enough slip rings to make it an endless rotation. But with this approach we have about plus minus 220 degrees of movement freedom, and I think this is enough for the first operation. Then the cables all run here, also from the motors, go inside there, under the bracket here, and getting out there. So from here I will use some cable tubes to go to the controller, I think, because there's so less space to guide the cables inside. Remember there, this gear has to sit somewhere there, and the motor will be somewhere there. That's the next thing I'm printing. So let's take a look to the CAD files. This is what I've got so far, and here this is the bottom motor is still missing. So if we hide this one, so you can see the assembly I've told you on the robot arm. Was the transmission, and these are the big bearings who are still missing. If we just take a look inside, here you see the motor, and with this transmission going upwards here and here. And now take a look inside. We have a motor for the rotational joint with its transmissions here, and then we get here's the wrist attached. It's holded with these two bearings, and then we have the wrist, can hide it. There is the drive pulley, the twisted belt. Here as a printed gear. In the robot I used aluminium one. Then we've got the transmission here. There you have the encoder attached, and this is the wrist. You can also hide it with the robot servo, and also a bearing to get the straps out of the servo mounts. So that's the construction for now. You can download all the files on GitHub. So what is to do next? As I said, I wait for the bearings. I've got a rotational base on eBay. I think it's some furniture part, and I will use this for a first test, but it's just a prototype and not for the final version, because I think this is rather difficult to get. So I want to use as much standard parts as possible, so it's easy to assemble for other people. So thank you very much for watching. I'm thinking about doing a video about some tips and tricks for assembling or 3D printed part next week or so. So stay tuned. See you.